Next, I'll be showing you how to solve the ALEKS problem, provide hybridization and molecular geometry. So what ALEKS is basically asking is for the hybridization and then the molecular geometry, really the shape for this one. And then the rules for this is that single, double, and triple bonds only count as one electron group. Lone pairs only count as one electron group, and ensure that we're satisfying the octet rule. Next, we'll go to the handout that I have. Feel free to screenshot or go to the description to download a copy. But the sections from the handout that we're going to use is total domains, which pretty much aligns with electron groups, bonded atoms along with lone pair, and then we're going to identify the molecular shape based on this data that we have, and then the hybridization. So starting first, we'll look at the first compound. I want us to focus on CH right here. And so we'll start first by counting the electron groups around it. Remember, we have 1 right here, 2, even though it's a double bond, this is going to be number 2 because it only counts as one bond. And then right here, Alex could probably trick some people up with this one, but just remember you have a carbon attached to hydrogen. So if you want to write it right here, instead of like having it connected right there, you feel free to just write an H right there to kind of picture it, and it's bonded there, and you have 3. Now the trick for this one is you have 3 bonds. So I would write this as 3B. And you go to your hybridization sheet right here. We know that it has 3 electron groups. So for hybridization, that's going to be sp2, highlighted here. sp2. Next up, what we want to do is identify the shape for this, our 4D carbon. So we see that it has 3 bonds. So we're going to go back to the hybridization sheet. And right here, we go to the total domains 3, and then we come over here to this section where we have bonded and lone pairs. Because it has 3 bonds, we're going to circle this. And the molecular shape, when it has 3 bonds, is trigonal planar. So from the drop down here, you could just type, or however you want to write, just write trigonal kind of planar. Sorry, with the mouse on here. All right, next up, we're going to go to the next highlighted group, which is going to be this nitrogen. We see that it has, we can count together, lone pair, which we said only count as one group, and a triple bond, which counts as one group. So overall, it has 2, and it satisfies the octet rule because, again, each bond, each triple bond, we could pretty much say 6, and then these 2 electrons right here make it 7, 8, satisfying that octet rule. And we see here that we have 1 bond, and then 1 electron group. We could write that down. We'll go to our hybridization. So in total, we had 2. So go to our hybridization. We have 2 right here. So hybridization for it is going to be sp. And then we're going to go back to our hybridization sheet, and we see that we have 1 bond, 1 electron group. So right here, we have 1 bond, 1 electron group, and of course, both of them are linear. So we'll go back to the question. It'll be a drop down, and we're going to select linear. The last one, we have a oxygen, which is attached onto a CH group, 2 lone pairs, and then again, however you want to picture it, you could just write it out here, the hydrogen, if that helps. And then we're going to count our groups around it. So we got 1 that's attached to the CH. We got a lone pair of electrons here. This is 2. A lone pair of electrons here, which is 3, and a single bond to hydrogen right there, which is going to be 4. So in total, we have 4 bonds, and then we can break it down by bonds and electron groups. So for electron groups, we got 1, 2. So I'll write 2E. And then for bonds, we have 2. 1 right here, 1 right here in this area. So we can write 2B. I'll go to my sheet. So in total, that'll be 4 bonds. So go to my sheet right here. This falls under 4. So the hybridization over here is going to be sp3. And then next up, we go back to our handout here, and we'll look to where we have 2 bonds, 2 electron groups, and that matches up with the shape bent. So we'll come back, and then in the area right here, we'll just write bent. So again, not too hard. Just going to take some practice understanding the sheet to help you understand your shapes as you go throughout this section of hybridization and shapes and whatnot. But again, if this helped you or any of your classmates, feel free to like, share, and subscribe to my channel. Thank you.